Ladies and gentlemen, welcome to machine learning. In this video, we will cover a short topic regarding the probability functions. Let's jump right in. So the probability of observing an event can be expressed with a function, and these functions can be either discrete or continuous. So we have the discrete case and the continuous case. So if we have the discrete case, we call the probability functions a probability mass functions, so PMF. Probability discrete of an event xi. In the continuous case, we call it the probability density function, PDF. So probability continuous of a specific xi. If we now sum over all these the probability density function, we will get a cumulative density function, so CDF. So the CDF gives us a probability that x, our variable, will be smaller or equal to our x star. So in the discrete case, we have the probability of x being smaller than x star is equal to just a sum of all x's that are smaller or equal to our probability. And in continuous case, if we're interested in the probability of x being smaller or equal to x star, we have to take the integral from minus infinity to x star over our probability density function. This is a visual representation, so p of x is our function, so our probability density function, and this is an integral of our function and will give us the cumulative function. So if we're now interested in, let's say, what is the probability of having, let's say this is 0.5x, we can just insert that number into our continuous function, and we see that this value is equal to our probability of x being smaller or equal to 0.5, or let's make it a capital X, 0.5x, because we're up to x. This might be still a little bit confusing, so we can have an example. So let's say we have a probability function, probability density function, which is 3 times x squared. So it will look something like this. And now we're interested, well, what is the probability that our x is larger than 0.5 and smaller than 1? If this goes up to 1, we're interested in, well, what is the probability of our variable falling into this interval? We do that by applying our integral rule, this one right here. So we take the integral from 0.5 up to 1 of our function, which is equal to just inserting 0.5 and 1 into our x cubed, and it will give us the result of 7/8. So the probability of our x falling in exactly this interval is 7/8. And now we can ask, well, if we have this probability density function, what is the probability of having p is equal to 0.3? We again apply our rule and see that if we have an integral from 0.3 to 0.3, regardless what is here, we will get a 0. So the probability of having, if we have the probability density functions, the probability of having one specific probability of our x is equal to some specific value will be actually equal to 0. We can only determine our x in a certain interval. I hope this video gave you a better understanding on how to work with probability functions. We will use them in the later videos. So if you already know everything about probability functions, feel free to go to the next video. Thank you very much for your attention, and I'll see you next time.